Hey there, class. Mr. Pusky here. Hope we're having a good day so far. We're continuing with Chapter 7, even though we're doing 6.5 today. This is because we're going to be introducing a concept in 7.6 that's going to be important to know how to do 6.5. So we moved this to in front of 7.6, at least for this year. So the name of this lesson is Graphing Linear Inequalities in Two Variables. Our essential question is, how do we graph linear inequalities in two variables? All right, so a linear inequality is going to have x and y, and it's going to look like a linear equation, but it's going to have an inequality like less than, greater than, less than or equal to, greater than or equal to, something like that, basically, okay? So the first thing we're going to be doing is we're going to be checking whether something is a solution to an inequality, and all we have to do with that is we need to plug in x and y and simplify. So let's go ahead and do number 1 here, see how we do. So we're plugging into the equation, or the inequality, 2x plus 5y is greater than or equal to 10. So we're literally going to we're going to call x is going to be 1, and y is going to be 2. We're going to plug into this equation. So we have 2 times x, which is 1, plus 5, which is, and then y is 2, greater than or equal to 10. Okay, so what is 2 times 1? Well, that's going to be 2. 5 times 2 is 10, greater than or equal to 10. This is how we show our work, too. What's 2 plus 10 going to be? That's 12. Is 12 greater than or equal to 10? The answer is yes. This is going to be a solution. That's all you have to do. All right, see if you can try B and C on your own. See how you do. All right, welcome back. Let's go ahead and do this again. We're going to call x is 6, y is 1. We're going to plug into the equation, or inequality, sorry. X is 6, plus 5 times y is 1. Greater than or equal to 10. 2 times 6 is 12. 5 times 1 is 5. What's 12 plus 5? 17. Is 17 greater than or equal to 10? The answer is yes. This one is also going to be a solution. And then we have 0, 1. We're going to call that x and y again. So we have 2 times x is 0, and y is 1. So we have plus 5 times 1. Greater than or equal to 10. 0 plus 5 is greater than or equal to 10. 5 is greater than or equal to 10. Is that true or not? That is not true, so this one's going to be not a solution. All right, that's how we test whether something's a solution to an inequality or not. We just got to plug it in and see if it's true or not at the end. All right, moving on. All right, now we're going to talk about graphing linear inequalities. So this is very similar to graphing lines. Okay, step number 2 is one way you can do it. I like to do step number 3. I think step number 3 is a little bit easier, but let's go ahead and fill in these blanks here. So step 1 of graphing a linear inequality is to graph it as if it said equal to. And so basically if it were y is greater than or equal to 3x minus 2, you would graph your b first. Then you would use your slope for the second part, right? You'd use your b, and then you'd use your slope to find the other parts on the line. But we have to be careful because after we graph it, we're not going to use a solid line all the time. We may use a dashed line or a solid line. And if it's less than or equal to, if it's not, or less than or greater than, that is, we're going to use a dashed line. Okay, if it's not equal to, we're going to use a dashed line. That is very similar to if we had a number line, we had -1, an open circle. This would be x is greater than -1 for an inequality like that. So a dashed line is kind of a similar version of that. It's going to be like an open circle on a regular inequality like that, okay? And then when we have equal to, we're going to use a solid line because that means it's part of the solution. If it's less than or equal to or greater than or equal to, we're going to use a solid line, okay? All right, so the number 2 way to do this, I don't like all that much, but I'm going to just show you what to do. You could, if you want to figure out which way to shade. So linear inequalities, what we're going to do is we're going to graph the line, and then we're going to shade above, below, or left or right, basically, okay? And we're going to shade toward the true side. Just like up here with this example, we shaded, to the right or to the left, basically. We're going to be doing the same thing, but now we're doing it in 2-dimensional space. We're going to be shading like a whole, half of a plane, basically. We're going to do like half the paper, basically, kind of thing, okay? So number 2 is you're going to choose a point not on the line to test an inequality. And if it's true, you shade that direction. And if it's false, you shade the opposite direction. But that's kind of similar to what we did with the other inequalities before. But I don't like that method all that much. I think the method that we're going to use is down here, which is a little bit better, okay? So for number 3, we have or. It says get y alone and shade above or below. I think this method is a lot better. So if you solve for y and get y by itself, if we have y is less than or y is less than or equal to, we're going to shade below the line. And that makes sense because it's less than, it's going to be below, right? And likewise, in the opposite direction, if we have greater than or equal to, we're going to shade above the line. Okay? And the last thing we have to talk about is x is less than or equal to, because that one we're actually going to shade to the left. Because if you remember, x is equal to 4 is a vertical line. It's a vertical line, so we can't shade above or below a vertical line, right? That does make sense because it's already a vertical. And then the opposite direction, if we have greater than or equal to, we're going to shade to the right. Okay? So we're going to jump around a little bit. Actually, the problems that I gave you on the actual homework here, I don't like all that much. So we're going to jump around a little bit. We're going to do 3, then 4, and then 1 and 2. So let's go ahead and do that. We're going to jump to number 3 first. All right, we're going to rewrite our problem here. Some of these problems, they want you to actually solve for y and all that stuff. We're not going to jump into... I'm going to go ahead and do this a little bit easier for you, okay? So we're not going to use this equation. What we're going to graph is we're going to graph y is greater than negative 3x plus 4, okay? Basically, I solved that by dividing by negative 1, but I don't want to add solving on top of just graphing here because the graphing is hard enough as it is, okay? So we're graphing y is greater than negative 3x plus 4. First things first is the y by itself. The y is by itself. So now what we're going to do for every single problem here, I like to circle this inequality and draw a little line over here. We're going to talk about what kind of shading, what kind of line we're going to have here. First of all, it's greater than. So it's going to be, is it going to be a dashed or a solid line? Well, it's not equal to, so it's going to be a dashed line. Okay? It's going to be a dashed line. And then if it's greater than, are we going to shade above or below? Well, it's greater than, so we're going to shade above. So it's going to be a dashed line, and we're going to shade above this line right here, okay? All right, so let's go ahead and graph this now. So we're going to graph it as if it were y equals. You're going to graph it, it's not y equals, we're going to graph it as if it were y equals, okay? So we're going to graph y equals negative 3x plus 4. What's the first point that we graph for this one? Well, we're going to graph the 4, right? We graph our b, so we're going to go up 4, 1, 2, 3, 4. There's our first point. And what's our slope telling us to do? Well, it says to go down 3, right 1. That's our slope is negative 3. Down 3, right 1. Down 3, right 1. Down 3, right 1. And we're doing a dashed line like we talked about because it's not part of the solution. The line is not part of the solution. Okay, that's how we graph that part. Now we need to shade above. Now which way is, this is kind of a steep line. Which way is above? The way I like to tell if it's above or below is take a point and draw a line straight up and straight down. And you can kind of tell that above is going to be to the right of this problem. So we're going to shade like this. Okay? And this is going to be our solution. There's actually infinite solutions in that shaded area, and that shaded area goes on forever to the top right. Okay? And then everything below that is going to be not part of the solution. So if you were to plug in any number in this area over here, they would all satisfy this inequality right here. The y is greater than negative 3x plus 4. They would all work. Any point over here would work, but every point over here would not work. Okay, it's not part of the solution. So basically, the shading is including all the solutions. Okay, but that's how you graph it. Is you graph the line, make sure it's dashed or solid, and then shade above or below for the most part. All right, ready to make it a little bit more challenging? All right, let's do it. So we have sketch the graph of x minus 2y is less than or equal to 2. So for this one, we need to get y. First of all, is y by itself or no? No, so we need to get y by itself. How do we get that negative 2y by itself here? Well, I'm going to subtract x from both sides. So I'm going to have negative 2y is less than or equal to negative x plus 2. All right, what's the next step to get y by itself? Well, we need to divide by negative 2. So we're going to get y is... Now, do we need to flip the inequality or no? We actually do because we divided by a negative here. All right. All right, now how does this divide? What is negative x divided by negative 2 going to be? Well, that's going to be 1/2 x. And what's 2 divided by negative 2? Well, that's going to be negative 1. Okay, so solving for inequalities is going to be very important for this problem. Okay, now we need to go ahead and graph this. First things first, we have y by itself. Now we need to check this. Is this going to be a dash or solid line if it's greater than or equal to? It's going to be a solid line. And it's shaded above or below if it's greater than. It's going to be shaded above. Solid and above. So let's graph the line as if it were y equals. It's not y equals. We're going to graph it as if it were y equals. So what's the first point we graph? The 1/2 or the -1? We graph the -1. We go down 1, put a point. What's our slope telling us to do? The 1/2. Up 1, right 2. Up 1, right 2. Up 1, right 2. We can also go the exact opposite direction, which is down 1, left 2. Down 1, left 2. Down 1, left 2. We're going to draw a line. There's our solid line. We're shading above. So above, you take a point, draw a line straight up. That's above. Above is up here. This one probably is easier to tell, but it's still good to check if you're doing it right. Okay, so all this area, and I'll go all the way to the line here. I didn't really draw it all the way to the line, but it's not a problem. All that area above there are all solutions. Everything below this line are not solutions to that inequality. Okay. All right, so now we got two examples of the normal graphing. Now let's talk about x and y graphing. This one's going to be a little more challenging. All right, so we have sketched a graph of x is less than 4. Okay, so how would you graph the line of x equals 4? Is that Hoy or Vux? That is Vux. So this is going to be, it's x equals 4. So it's going to be a vertical line through x equals 4. Right? Okay, it's a vertical line through x equals 4. Let's take a look at this now. So if you look above here, we're doing x is less than. Is that going to be shaded to the, is it solid or a dashed line, first of all? It's not equal to, so it's going to be a dashed line. And is it shaded to the left or to the right if it's x is less than? It's going to be shaded to the left. Okay? All right, so we're going to do a dashed line through x equals 4. So a vertical line here's x equals 4 like this. There's a dashed line. We're shading to the left. So we're going to go all these areas to the left here is going to be solutions. Oops, sorry, my speaker went off. Okay, so yeah, all these are going to be solutions. That's all we have to do, okay? I probably should have done example 2 first, but that's okay. That's what's the same thing, okay? So if it's x is less than 4 or x is greater than or equal to -2, that's a vertical line through that number. Here's 4 right here, okay? And you need to shade depending on which direction it says. If it's less than, you shade to the left. Greater than, you shade to the right. Not equal to or just greater than or less than is going to be a dashed line. Equal to is going to be a solid line. All right, let's talk about the last example now. We have this one. We're actually going to change this from that to y is greater than -3. All right, so is this Hoy or Vux if it's y equals 3? Y equals -3. This is going to be Hoy. So y equals -3. And it's a horizontal line. Okay, so it's going to be a horizontal line through -3. Here's -3. And it's a dashed line, like we said. I kind of gave that away, but this is going to be, let's go down here. It's a dashed line, because it's not equal to, and it's going to be shaded above or below if it's greater than. It's going to be shaded above. It's going to be a dashed line shaded above. All right, and there's our final example for today. All right, thank you for watching. Have a great day, and we will talk soon.